Swayam Prabha. Digital India. Educated India.
Now we are talking about unsteady flow in open channel. So when we were discussing, say, open channel flow classification, there itself we did mention about unsteady and steady flow. There are different classification we gave, and out of all those classification, one classification we made, that was the classification based on variation of flow parameters with respect to time. And when the flow parameters were not changing, or when the flow parameters do not change with respect to time, then we refer that as a steady flow. So whatever depth we are getting at a particular section, or maybe say a different section, this depth at different section will not change with respect to time. Maybe it is gradually varied flow, that is, the depths are different in different sections, but that is remaining as it is with time. With time it is not changing. So that sort of flow we were considering under steady flow, and we have discussed a lot on steady flow till now. And then when these depths are changing with respect to time, say at a particular section this is the depth we are having, in the next moment we are having another depth. So that sort of change when occur, then that is coming under unsteady flow. And our discussion, today's discussion, is on unsteady flow. Well, and when we talk about unsteady flow, when the thing changes with respect to time, generally it is associated always with wave. It is, so unsteady flow is always associated with wave, Well, now why this is important for us to discuss unsteady flow when we talk about wave. Now these wave can cause, see, people started discussing on some of the topic, or started working on some of the topic, when we find that yes, it is creating problem to us. This is one reason. And another is that yes, sometimes we try, okay, this is there, if we study further more in that, then we can utilize this for our need and for the betterment of the mankind. So that way we start our we start our working on a particular topic, like this wave, that is the unsteady flow, where wave is one of the important aspect, or it is always associated with that. Now as we understand that wave sometimes can create a lot of problem to us, as well as by we can use this wave for harnessing energy also from that, like tsunami wave create a lot of problem. Now this is a very popular topic known to all. Similarly, if the dam fails, it can create a lot of waves. So like that, this is becoming more important for us. Then these are the waves. Well, and we will be discussing first today basically what the waves are. And when we just simply say wave, well, that is known to all. In our day-to-day life we encounter those waves, but well, but technically we need to understand what wave is and what are the different type of wave, that we need to understand. So as a definition, first we need to understand some terminology of the wave. Well, as a definition we can say that temporal variation in the water surface which propagated through the fluid media, is called a wave. Well, so wave is generally always it is propagating. It is propagating through the fluid media, and here temporal variation means variation of the surface generally is visible here. So we normally understand that temporal variation of water surface. So this variation of water surface is propagating. So in fact, here one important point that we need to understand, that we are talking about the propagation of water surface, whether the actual water is propagating or whether water is really transferring from one point to another point is not coming. By wave we mean that there is a temporal variation in the surface, like that you can see here that these are the variation in the surface, and this surface variation is propagating, and that is what is wave. We are not concerned whether water itself is moving from this point to that point or not. Of course, in many cases water might be moving, in some cases water may not be moving, or the mass actually may not be moving or may not be transferring basically. Well, then we need to know about some terminology that we can see. About a wave, we need to know some of the terminology. Of course, we have learned about this terminology perhaps from our very preliminary classes, but still let us repeat so that sometimes still we may have some confusion about those terminology. Well, one term we are popularly using is wavelength. Well, so if I draw the wave, well, let me draw the wave on the wave itself, just one line. Say if this is the wave I am drawing, and as you can see in the photograph also, that this is one of the highest point of the wave, and this is the lowest point of the wave. Well, in my diagram this is the lowest point of the wave, and then if this is the wave, then what we mean by wavelength, what we mean by wavelength. So this point, and then another term, this is crest of the wave and trough of the wave. Well, this is called, the highest point is called crest of the wave. These are crest of the wave, okay, and this lowest point that we refer as trough of the wave, okay. Then what is meant by wavelength is basically we can define is the distance between the crest to crest, but of course the real definition should not be like that, that it is not basically the distance between crest to crest. If we take this as a trough and there is suppose another trough on this side, well, I do not have space that much, but suppose this is another space, then trough to trough distance is also wavelength. And if it is a symmetrical wave, then this will be same, this will be same, and that's why by wavelength we define that it is a distance from corresponding points, we can say corresponding point. Even if we start from here and then if we go to, suppose after one cycle we are going there, then this corresponding points if I join, this distance is also, say, we can consider as wavelength. This can also be considered as wavelength. So it is basically the corresponding distances between the two say consecutive points, consecutive crest height that we are getting, and then this we can define as wavelength. And then amplitude. What is amplitude? Amplitude of the wave. Well, we can draw a line like this actually, which is in fact is the, say, mean water level, mean water level. When wave is forming, well, it is not necessary that always this mean water level will be at the central point. It may not be always like that, but sometimes that wave can go above the mean water level. But so suppose it is the mean water level, then by amplitude, say, we call this as the amplitude of the wave. This is the amplitude of the wave. Well, then with this very basic definition of some of the parameters of wave, that or terminology of wave, let us proceed to the discussion that how we can have different types of wave, or on the surface of water how we can have different types of wave. Well, One of the most commonly encountered phenomenon of water surface is the wave. Every day when we are traveling over the wave, then when we are traveling over the say water, we find that wave. Even a boat is creating wave, which is also wave. So that way, different situation we see waves. But the wave can be, some of the wave important we are talking about here is the capillary wave one, of course. This capillary wave is very small in dimension, and this capillary wave is why it is called capillary wave. So when we create any disturbance, somehow if the water surface is getting disturbed, then from its normal condition, then this will be some force will try to restore the water surface to its original position. And in case of capillary wave, the surface tension force is the force which restore or which try to restore it to its original position. So what we can see that in capillary wave, restoration of the disturbance to the surface is achieved due to surface tension of water, and these are what the capillary wave, we get ripples in water. These are basically capillary wave. Its wavelength is very small, like in centimeters, very small centimeters. And then we can get another type of wave that is called elastic wave. Now of course, in case of water, if the fluid is considered as compressible, then only we can have this elastic wave, and in normal surface conditions, say we do not get that as elastic fluid. But of course, in some cases when that is important, we need to consider that fluid compressibility, and so fluid compressibility is responsible for formation of such wave. Other formation means it is trying to restore, then again it will become because of compressibility, if it is this wave is forming, then this elastic force will try to restore it, then again this will be disturbance will be coming. So like that, when this wave is forming, that we term as elastic wave. Well, then when the wave are of larger size, waves are say length of the wave is increasing little larger, then height will also automatically increase to some extent, and then this surface tension force cannot restore those things, or in that case when height increases, its weight of the wave become more significant, and this governs the entire wave formation and then restoration. So that sort of wave we term as gravitational wave. So weight of the fluid in gravitational wave, the weight of the fluid, that is the gravitational force, is the dominating force, and that kind of wave we refer as gravitational wave. Well, and for our discussion we will be concentrating all on this gravitational wave. Well, now as I was discussing at the beginning itself, that we are interested for the wave because in nature naturally also we are getting wave, and because of some of our activities we are getting wave in the water. In the sea we are getting wave, in the rivers we are getting wave, and these waves create many a time problem to us, or sometimes we can utilize this wave for our betterment. Again, just the river stream, we can harness energy from this high wave, sometimes tide. So now let us see that waves that are formed and due to different causes, and particularly we are mentioning some of the large wave that we get. Well, following are some of the example that causes large wave. Okay, these large waves are generated in the sea by tide, which occur due to gravitational attraction of the moon. That is known to almost all. I mean, from the school level itself, we know how the tides are forming. So this is what the tide creates some wave, and that waves move in the estuary. This wave moves into the backwater also, and we can see this sort of wave. Then tsunami, that need not be mentioned. Now it is very popular term and known to all, that it is a kind of wave that is initiated by an earthquake if it occurs below the sea level, sea water that is on the bed, and then it can give rise to some high waves, and if it propagate into the earth surface, I mean towards the bank, or say towards the land, I would like to say, because bank is not the term that we use in sea, towards the land, then near the land it may become very ferocious and it can cause lot of damages. So this is what one wave. And then say huge wave may form in the river due to failure of dam. Well, now dam are constructed to have better utilization of water, because that is known to all that with dam we can have lot of benefit, and dams are serving well. Of course, some oppositions towards the dam is also there, because that it obstruct the natural flow, so environmentally it cause some problem. Well, now we are not going to that controversy, but when this sort of dam if fails, then huge wave start forming. That means all the water will be just moving, rushing down into the downstream area and submerging all the things that is lying in the downstream. So that way it can be, if that, it will depend on the size of the dam. If the dam is a very large size, say 300-meter high dam, then the wave formation or wave that will form on the downstream will also be of very large size. Maybe 15-meter high wave will be flowing. So that means, say 15-meter means you see that it will be a, say 3 to 4 story building, like that it can move. Well, so these waves you will first study on this dam break wave started when there was a threat. There was a threat that, well, during Second World War there was a threat that some dams can be failed, and then this may be one strategy of causing damage to the downstream area by the enemy. So enemy can put bomb, and then this way they will generate huge wave by that process, causing destruction to the reservoir which were constructed for benefit of the people. And in that context, people were interested to know, scientists were interested to know, planners were interested to know that at what time this wave will reach which place, how much will be the depth, what will be the submergence, and that led to the study of dam break wave analysis. So this is one where we can have large wave. Then again we can have large flood wave. This is, of course, dam break wave is also a flood wave, but we can have large flood wave may generate due to heavy storm. Generally we may not have that feeling that, well, heavy storms, a thunderstorm is occurring in a catchment, and if that catchment is hilly catchment, suppose very steep slopes are there, then all these wave or all this water may accumulate quickly, and huge amount of water might be flowing or may flow into the river within a very short time and causing huge wave. And this sort of unsteady flow which generated from thunderstorm, or that we call cloud burst, from that if it occurs, then it can cause great damages. In fact, in the northeastern part of India, one stream from Meghalaya that came, and in a storm about 200 people were washed away. About 200 people were washed away from an area which is lying on the western part of the Assam. So that way this sort of wave can also cause lot of damages. Well, and these are some of the cases I have just put, which are of course natural and of course artificial when we talk about the dam break case. And sometimes we, in some channel, suppose we have gate, and suddenly if we open the gate, suppose on the gate we are storing water on the upstream, then if we suddenly open the gate, the water will be moving with some wave formation. So that way also we can get wave, that is man-made wave, or we can create wave like that. Well, with this some understanding where we can have wave and how this is important, or study of this unsteady flow, why it is important, because we need to know how this wave will be moving, and to take care that if it is coming, if it is trying to do some devastation, how to take measures to just avoid those devastation. So those analysis is required, and that is very much important for hydraulic engineers, and that way we need to study this wave in unsteady flow. Well, then let us see how this gravitational wave we can classify. So wave can be classified on the basis of, first is physical classification. Well, by physical classification we mean that based on its shape, and say how the wave looks like, that way also we can classify. Then whether it is say higher than the normal water level, whether it is lower than the normal water level, so that way also we can classify. So on different bases, following different bases, we can classify it on the basis of physical classification. And then again, type of wave. Sometimes we find that waves in a particular wave, the mass is not moving, but we are having a wave like in the sea, we are having that mass is not exactly moving, and then so average movement of mass is 0, but in some cases like dam break wave, the mass itself is moving, rushing down. So that consideration also we can classify. So that way, from different way we classify the physical classification. There will be some subclasses will be coming later. And then the variation of depth with space, that is also one way of classifying, that is how quickly the depth is varying. A variation of time is not considering here, because otherwise also we are talking about say variation of time, it is unsteady flow. But in an unsteady flow also, how this depth, so wave means there will be a variation of depth on the surface. So how quickly these, or within what space limit the variation is occurring. If it is suppose very sharp change, then we can say that there is a wave front, and if it is not a sharp change, then we will be finding a smooth variation of wave. So that way also we can classify it, and more distinctly we will be discussing that, of course. Then in some case of wave, this is the extent of depth disturbance. Well, by this what I mean is that depth disturbance means up to which depth. Say wave is forming on the surface, then up to what depth this is causing disturbance to the entire flow. So based on that also we classify the wave. Well, let us see one by one what are the classes. First we are talking about physical classification, that oscillatory wave. Now in this oscillatory wave, say if this is a mean water level, if this is a mean water level, then the wave is forming like this, wave is forming like this. There will be a crest and trough, of course, and then what is happening to the water here? These are basically moving like this. At the crest it is trying to move like this, but when it is going to the trough, then trough part is moving like this. That means from this side water is moving like this. In fact, we will be getting ultimately a circulating flow like this, that is this part it is going like that, and this part is so basically the water is circulating, or it is just moving in this form, and net mass transferred from this portion is not that significant. So net mass transport can be considered as 0, and this sort of wave are called say oscillatory wave. In sea we get this sort of wave. Sea wave is one example of this sort. We can have in other places also, but this is one example. Then another type of wave is called translatory wave. Translatory wave. Here, say this is the mean water level, then wave will be, water will be moving, when it is moving like that, water will be moving this way. And suppose this is the wave I am drawing, and the water is moving like this. Suppose this is the wave portion, let me draw, and then we can see that this is the water is moving in this way, and then this depth will be higher than the say mean water level, or say water level, normal water level here, and then it is moving like that. And here what is happening, the entire mass is moving from this point to the downstream point. Well, that sort of wave we call as translatory wave, like the wave as we were discussing in dam break flow, this water is moving down, and that we refer as translatory wave. Of course, some more classification are there, and in translatory wave we can have solitary wave and we can have train of waves. Well, By solitary wave, when we have a single wave, then we call this as a solitary wave. And then when we have a trains of waves, say this is one wave, then another wave is coming, then another wave is coming, like that, when we get, then this sort of waves are called, that is, one wave is followed by other, then it is called a train of wave. Well, for many of our analysis purpose, we sometimes form solitary wave and then we analyze how we can derive the different relationship between this wave height and all. Well, then let us see, again we can classify this sort of wave based on its shape. Well, shape, say one type of wave we call as monoclinal, that is single phased wave. Say water is coming like that and it is going like that. This is also a wave, and this has a single phase. This is the phase of the wave. We are not having two phase here, so it is a single phase. So that sort of wave we also get, and in many cases when we start this wave, when we get a wave by, say, opening the gate, then we get this sort of single phased wave. And then we can have two phased wave like that. Here we have, this is one phase and then this is another phase. Phase 1, say phase 2, we have two phase. Well, so in two phase wave, again there can be symmetrical wave or there can be asymmetrical wave. Well, now what is meant by symmetrical wave? When we get a wave of this type, that is, it is rising, this is, say, ascending part and this is a descending part, and we have a peak here. So this slope of ascending part, slope of descending part and the peak, I mean on the other, both side of the peak, the ascending part and descending part, these are symmetrical. So this sort of wave we call as symmetrical wave. But many a time we may not get this sort of symmetrical wave. Well, we can have a wave of the type that ascending part is rising gradually and then it is coming down very steeply. So when we get this sort of wave, then it is called as asymmetrical wave. So here you can see that it is rising steeply, then it is coming down very sharply. So rising flatly, I mean slowly it is rising and then it is coming down steeply. So that sort of wave, it can be in other way also. I mean it can rise steeply and then it is suppose falling down in a very flatter way. So this is also possible. I mean just when it is not symmetrical, then we refer it as asymmetrical wave. Well, then say another physical classification we generally draw, and this is of course important for some of our study, and that we call as a downstream wave and upstream wave. Well, not necessarily, though generally a feeling is there in our mind that when water is moving in a particular direction, wave will also be moving in that direction, the wave when it is moving. Well, but it is not necessary. Wave can sometimes move in the opposite direction to the movement of the water. Actual water is moving, suppose, in downstream direction, and a wave is moving in the upstream direction. That can also be possible. So when we see that the wave is moving in the downstream direction, well, I can give you some example, then it is called downstream wave. And when it is moving in the upstream direction, then it is called upstream wave. In general, say water is moving like this and then it is the bed, say water is moving in this part, say this is the normal level, and then water from some cases, or it is coming like this and then it is moving like this. So earlier it was moving like this, then this wave is, this is the water which suppose velocity v it is moving, and this wave is coming and this wave is also moving in the downstream direction, like the flood wave. Say in flood, suppose this was the wave water level, this is the water level, and then a flood has occurred. So flood water is coming and it is increasing the level of water, and this wave is moving over the normal level of water in the river, and this is moving in the downstream direction. So this is called downstream wave. But in some case, the wave may be moving in the upstream direction. Suppose say this is water was flowing like that, and say suddenly we have closed this part, and then water will be moving in this way, then it is going like that, say gradually it is, this wave is moving in the it is also becoming a upstream wave. I'll give another example, like say let me take one example of dam failure. Suppose we are storing the water here, and then there was a dam, and suddenly we are removing this dam, or this dam has failed. Then, well, if I remove this dam, now say this axis I am drawing, what will happen? That water will be getting released like that, and it is moving this way. Then in the next moment, water will be coming this way, and then it is moving this way. Now this part is also a wave, that is, this wave is moving in the upstream direction. See, water is moving in the downstream direction. That is what the point. Water is moving in the downstream direction, but this wave is moving in the upstream direction. This is moving in the upstream direction. In the next moment, say it is continuing, next moment it can be coming up to this point. So here this wave is moving in the downstream, in the upstream direction. So this is what is called upstream wave. Well, but of course, when a dam fails, that is the wave that is moving into the reservoir. The wave that is moving into, this is what the reservoir side. This is what the reservoir side, and this is what the river side. River side means, I would like to say, it is the downstream. So when the wave is moving into the reservoir, water is just, or the wave is forming, that wave that is moving into the reservoir are the upstream wave. But of course, the same water, we are having this wave which is moving into the downstream side. These are again downstream wave. That means by this what is clear, that although we are classifying this as downstream wave or upstream wave, but in real field we can get a surface which may contain, say this is a surface we are getting, we can get a surface which may contain, or one part of the surface may be containing a wave which is moving upstream, and then other part of the wave, this is containing a wave which is moving downstream. So not necessary that we will be getting one downstream wave or one upstream wave, we can get in combination as well. Now there is another classification we make as positive wave and negative wave. Well, so what do you mean by positive wave? Say our normal water level is this one, and then if the wave height is greater than the normal water level, so then it is a positive wave. But if suppose this is the normal water level, and somehow we have blocked this one, and just I was drawing in the just previous slide that if I block this one, then water in this side partially block, or something has happened which has created the wave like that, and it is moving in this direction. So this sort of wave which is actually lower than the normal water level is called, and it may be moving upstream, downstream, it doesn't matter, but when it is less than the normal water level, then we call this as a, say, negative wave. So we can have positive wave as well as negative wave, and if we refer to our earlier diagram, then we can see here that in case of this wave, when a dam break case we were discussing, then here say negative waves is moving in the upstream direction. Because it is negative, its normal water level is this one, was this one, reservoir, and the level is lowering here because of the wave movement. So here we are talking this as negative wave moving in the upstream direction. And here, say our earlier water level may be 0, or maybe that we had some amount of water here earlier, but still when the wave is propagating on the downstream, the depth is increasing. So here we will say that positive wave is moving in the downstream direction. Here we are talking as negative wave moving in the upstream direction. So I mean, again, why I am emphasizing this point, that although we are giving name as downstream wave, upstream wave, positive wave, negative wave, in real situation there can be always, we need to explain, or we need to say what type of wave it is. In that case we need to say in combination, this is a negative upstream waves, this is a positive downstream wave, like that. So that what we have discussed were the classification of wave based on its physical characteristic. Well, then we can make another classification. This is variation based on variation of depth with space, and there we make the classification as rapidly varied wave and gradually varied wave. Rapidly varied wave. Now we have already discussed a lot on rapidly varied flow and gradually varied flow. So in fact, in reality we need not have much confusion about these two different type of flow. When it is unsteady flow, then we are getting this as wave, and then we are talking this as rapidly varied wave and gradually varied wave. But what are important point that we need to still mention in this part is that rapidly varied wave, it creates abrupt discontinuity by sudden opening of gate. This is we can create, but in some other situation also we can have rapidly varied wave. Not necessary that always we will have to have a gate, it is nothing like that, but just this is an example that when we create a wave that we get where the sudden discontinuity or abrupt discontinuity by sudden gate opening, that sort of waves are coming under this rapid wave form. These are surges we can have bores. Surges are nothing but a discontinuity like that. This we call as a surge. And then bores, that is during tide, that is in an estuary, when this sort of surges occur in estuary in the during tide, then we refer these as bores. And then hydraulic jump we have discussed already. This is also one kind of, say, rapidly varied wave. Well, and then in this sort of wave, this normal acceleration is significant as the water is moving this way, because water will be moving this way. So normal acceleration in this direction, is quite significant. We cannot neglect, when we are analyzing this wave portion, then we should not neglect this acceleration in the vertical or normal direction. I will not say vertical, because it may not be vertical. When we are drawing horizontal, then only it is vertical. So this but if it is a steep slope, it can be in this direction, but that, I mean, normal acceleration is significant here. And this sort of waves are forming in a very small reach of the channel, like hydraulic jump. The length where it is forming, that is very small. So the frictional resistance in the entire formation or the entire analysis of this wave we can neglect. So what I want to emphasize at this point, that we have two type of wave. One is rapidly varied wave, another is gradually varied wave. And when we will be dealing these wave mathematically, when we will be trying to model this wave, then we need to understand the physics behind it. And in that case we need to know that physics, when we are making some assumption in those in the process of simplifying the entire physical process, and so that we can represent it by mathematical equation, in that case we should not neglect the vertical or normal acceleration here, but at the same time we can neglect the frictional resistance offered to the wave by the side and the bed, because the length is very small. On the other hand, when we talk about the gradually varied wave, then it is say wave like that flood wave in lake, then in river, or say wave due to slow opening of gate. Again, that we can generate in a laboratory. In fact, if we open the gate slowly, then we can get this sort of wave. In a channel, we can block the water by gate, then we can have generate some height there, then gradually if we open, then we will be getting a wave of this sort. And similarly, if we close it gradually, then also we will be getting this sort of gradually varied wave. And in gradually varied wave, the wave will be like this. In gradually varied wave will be like this. And here the vertical acceleration, normal acceleration is negligible, that is there. We can neglect the normal acceleration, but the length of the entire wave portion will be quite large, and as such we should not neglect the friction in our analysis. So friction cannot be neglected, but normal acceleration can be neglected when we will be representing this wave mathematically. And this gradually varied wave is very commonly found in when flood comes, and then say flood routing when we do, then this sort of wave we follow well. Then we can make another classification. So that is what the classification based on extent of flow depth disturbed, flow depth that get disturbed basically. Well, so flow depth get disturbed. Now what we can see, you can concentrate in the slide, that when we write a deep water wave, the ratio of water depth to wave length, if this exceed the value 0.5, if it exceed the value 0.5, that means if we have a wave like this and say depth of water is y here, and say length of wave means, as you know, say there we can have the length of wave like that, or say from crest to crest if we measure, say from crest to crest we can measure, or say from trough to trough if we measure, and this is the say length of the wave. Then if this length ratio of the depth, water depth to the wavelength, say water depth is y and wavelength is L, okay, let me write capital L to represent the wavelength, then this value, if it is greater than 0.5, if it is greater than 0.5, then generally it is termed as deep water wave. Now let us just see what we mean by this. That means here, of course, in my diagram this y is smaller and this L is larger, but when we are actually talking about deep water wave, it will be like this, means this wave will be very small like that, and depth is very high, say y, and wavelength may be this much. Okay, if I draw another, then wavelength is this much. Okay, so this L by y is very small. This is the actual case, not this one, because this is just I tried to show what is y and L, but this part is the representation of this particular situation. Now you can see when we have this sort of L size and y size, then this wave formation will be disturbing the surface portion only. The entire water depth will not be disturbed. So this part of water is flowing as it is. This wave is coming in the surface, it is disturbing the surface, and it is moving over the surface. So it is not disturbing the entire depth of the channel, and that sort of wave is called deep water wave. In sea we get this sort of deep water wave. That means water depth should be much higher. Of course, it is again relative. Much higher means we cannot say that it should be this much meter or something like that. Relative to the length or wavelength of the wave, the depth should be comparatively larger. Then we can have shallow water wave. So what we mean by that, that ratio of water depth to wavelength is less than 0.05, about say 0.05, then we refer this as shallow water wave. So what is that? Y by L should be less than 0.05. Of course, there is a range or gap in between. We may put on this side if it is towards that, if it is towards this, we can put in that side. And exactly, of course, this barrier is being put, and in nature we can have anything in between. But this Y by L is larger means it is less than this value, means length of the wave is much larger than depth of the wave. Length of the wave is much larger than depth of the wave. Like that, if we have a wave of this type, and then say we see that this length of the wave is suppose 100 meter, and then say depth is of course, as per our sketch, if it is 100 meter, then say depth is say 5 meter, then we are finding that this water, when it is propagating, it is disturbing the entire flow depth, and because it is coming here, you can see just near the bed, and then it is creating disturbance to the entire flow system. And then say if it is less than that, even this will give you a value of say 0.05, but it is say less than that, then this will be referred as shallow water wave. Means in shallow water wave, the entire flow depth is getting disturbed. So for many of our analysis purpose, we use this concept, and sometimes depth average things also we take the velocity and all these things, as entire things are getting disturbed. So velocity at a point means we can take average depth, average velocity of the particular section, and that way we can carry out the analysis. And in dam break analysis, and of course again in the same waveform, we can see that at the front there may be steep surface which can be falling under say in a different category, but in the other part which is where we have this sort of condition, then we can consider this as a shallow water wave. And generally those wave in rivers we get shallow water gradually varied flow wave, and we carry out the analysis, we make the assumption in our development of the theory, and we study it in that form. Well, that way we can classify the wave in a different way. Then we need to know about one new term. Of course, we were referring to this term earlier also when we were perhaps discussing supercritical and subcritical flow. At that point also we were referring to this, and particularly when we were discussing control section or effect of control section on the water, where suppose in subcritical flow where the control will be there, when we were discussing that part earlier, then we refer to this particular term, that is the celerity. And in wave study we need to know, or when wave study means basically we are talking about unsteady flow study. In unsteady flow study we need to know clearly about this term celerity of the wave. Well, that definition wise we can say that it can be referred as speed of wave propagation relative to the fluid speed. That means fluid may be having a speed already. Suppose the water is moving with some speed, v, and then their wave is coming, then this wave may have some absolute speed. Say it is coming with the Vw speed, wave speed, but the water is also moving with a speed v. Then what will be its relative speed? That is basically say Vw minus v will be its relative speed, speed of the Vw or speed of the wave relative to the speed of the fluid media or say water media, we can call as Vw minus v, and that is basically called as c. So speed of the wave with respect to the speed of the media over which it is flowing, then it is called c. Now if we see, or if we create a wave in a stationary fluid, say water is standing, maybe in a tank we are taking water, and we can generate a small wave by just moving a paddle. Just one strike of the paddle will create a wave. So that sort of wave if we create, then say we are getting a wave and then it is moving, then this part of water is otherwise in static condition. then this wave speed, suppose whatever we get, this wave speed whatever we get, this will be the relative speed. And in that case, absolute speed and relative speed become same if the water is not moving otherwise. So that is how we define, but as per definition, it is the speed of propagation of the wave and the relative to the fluid speed. Okay. And the conventional symbol that we use is C. So C is the conventional symbol that we use for representing celerity of wave. Well, now the important point is that what will be the expression for C? What will be the expression for C? Well, that study, in fact, if we try to go into detail, we need to go too much deeper, but that is beyond our scope. But still, we will be just discussing some of the very preliminary things of these expression, how we can derive, and this how finally this expression can help us in many computational work that we will be trying to see. And an expression for C for wave of small amplitude, that was done for small amplitude, as we know what amplitude we mean, and 2D wave, that is we know what is this sort of wave, and then by neglecting the surface tension, by neglecting the surface, 2D means two-dimensional we are talking about, it is moving like this. I mean, this wave is vertical and then in the along the flow it is moving, so this we refer as two-dimensional wave. And by neglecting the surface tension and viscosity, because surface tension force sometimes for gravity wave, this become very insignificant, so we neglect that. But many a time, this is of course we should keep in mind that when we are analyzing the theory of gravity wave, if we do it in experimentation level in laboratory, then if the wave heights are become significantly smaller than that of the actual wave in the field, then the surface tension force may become sometimes dominating. But here, of course, neglecting this surface tension force and the viscosity, again say elastic condition we are neglecting, so viscosity is not coming here, internal friction that is not coming, so that way neglecting the surface tension and viscosity, he obtained the expression as, say, C is equal to root over G into L. L is the wavelength of the wave divided by twice pi, and 10s of say 2 pi y, this is again depth of the flow, and then this is the length of the wave. Well, we are taking this directly, and the derivation of this we are not bothering at this moment, and this is of course will require a lot of elaborate study, but we are taking this expression directly, that C can be expressed in this form. Now this expression, again when we are talking about this expression, in this expression we are neglecting surface tension in the derivation of this expression, we are neglecting the viscosity, and these are valid for small amplitude wave. Well, so this point we should remember, but this is the expression for wave, and this is used for many of our purposes. Now we can see that how this expression will take different shape for say a deep water wave and shallow water wave. Well, say for deep water wave, when our y by L is very large, then we can see the expression we have drawn, that C is equal to root over GL by twice pi and 10 h of say twice pi y by L. Now when our y by L is very large, y by L is very large, for large y by L, this 10 h twice pi y by L, this expression become equal to 1. So that gives us a simple expression that twice pi y by L, this tends to 1. And then if it tends to 1, what we get, that C tends to, or C become equal to, rather now we can write that C is equal to root over GL by twice pi. Fine. Then for shallow water wave, this y by L is very small. So when y by L is very small, for small y by L, then what will happen to this value, that is 10 of ten is of a very small quantity, that will become the quantity itself. So what will happen, that 10h twice pi y by L is becoming almost equal to twice pi y by L, and that leads to, say if it is twice pi y by L, L get cancelled, pi get cancelled, and then what we will get, the 2 get cancelled, y will be remaining, g will be remaining, and what we will get, that c is equal to root over g into y, and that is a very popular expression. That is a popular expression. This is when applicable for deep water wave like C, this is applicable for rivers. This is applicable for rivers. And if the channel is not prismatic, so in case of non-prismatic channel, then we can have C is equal to, because y we cannot use directly, then we can write root over G D, where D is the hydraulic depth, where D is the hydraulic depth. Okay. So this is what the expression of celerity, and what celerity we have understood, but now this expression C is equal to root over gy, that we can derive from the very first principle. From the very first principle means if we start from the continuity equation and momentum equation, then taking a wave, we can derive this expression. Of course, as we have already discussed, that this expression is coming from the consideration that A is very small, that is amplitude of the wave is very small. So when we will be deriving, we will also have to take that amplitude is very small, and then we can use our first principle, and then we can try to derive this expression. And for that, for derivation of this sort of expression, what we do, that conversion of unsteady to an equivalent steady situation. Generally, for say analyzing a unsteady flow situation, that is when depth is changing with time at any point, then it becomes a little bit difficult. I mean, how we will tackle this point. So what we can do, we can just change that to an equivalent steady condition. For example, say I can give you a practical example. Say now morning walk, evening walk, these are a very habit of the people. Now we do not have space to move, and that way what we do, we move on a walker, and then it is just simulating your walk system. So you are walking, we are walking on the walker, and then the belt over which we are walking is, when we are walking, the belt is moving in the opposite direction. So though we are walking, we are not moving forward, as if our condition is not changing. We are in a steady condition. We are not changing our position, we are in a steady position. How we are achieving that? That is, we are walking, but the bed or the belt over which we are walking is also moving in the opposite direction. Now suppose a doctor want to analyze some of the things, say I do not want to go to the medical science, but say when we try to analyze, suppose a heart problem, say how this person will behave when he is walking, then if the person is really moving, then doctor will find it difficult to analyze. So what he will do, he will put him on a walker and then a belt. So belt will be moving on the reverse direction and the person is walking. So the person is remaining on steady position, static position, and it becomes convenient for the doctor to study this person, how he will behave during the situation when he is walking. So similar situation we can create in water also. Say when a wave is actually moving with a speed c over maybe over a steady water or over a static water, suppose this velocity is 0, but it is moving with a speed. Then if we try to observe, this is moving. So rather than that, what we can do, okay, just like the belt, to the water we put a reverse velocity c, and then we consider that this wave is in static position. We are just providing a reverse velocity c to the fluid media, and then this wave which was supposed to move with a speed c will now remain in steady position. So this unsteady case we can just analyze by considering this as a equivalent steady case. Well, in the next class we will see how from considering this equivalent steady state we can analyze and we can see in a very simple term the expression for C we can derive, and then gradually we will be moving on to our other more important topic of unsteady flow. So, thank you very much.